right, so this is Chapter 11, Section 6, Analyzing Data. And we finally made it. I've been waiting all semester for this. Our learning objective is to calculate measures of central tendency and to draw and interpret box and whisker plots. Just because it's important to read, essential understanding is you can describe and compare sets of data using various statistical measures, depending upon what characteristics you want to study. Statistics is the study, analysis, and interpretation of data. One way to analyze data is by finding a measure of central tendency. So I want you guys to make sure you write down a measure of central tendency indicates the middle of the data set. The mean, median, and mode are the most common measures of central tendency. So make sure you guys write down each of these key concepts. I know it's a topic we've been studying for a long time, but it never hurts to have it written down and ready. So the mean is the sum of the data values divided by the data. The median is the middle value, or if you have an even number of data, it is the average of the two middle. So it's the mean of the two middle numbers. And the mode is the value that occurs most often. All right. Make sure you write down a bimodal data set has two modes. If a data set has more than two modes, then the modes are probably not statistically useful. If no value occurs more frequently than any other, there is no mode. So it has to occur. If every data point occurs twice, no mode. But so just something to keep your eye on. It doesn't occur very often, but every now and again I'll see an answer where there's no mode. All right, so let's see if we can do this. So the frequency table shows the number of trees in the yard of each house on one street. What are the mean, median, mode for the trees per yard? So the mean, we're gonna mean, median, mode for the trees per yard. All right, so we need the ratio of trees per yard. So our data set so this is 3/1. This is 4/5, 5/7, 6/4, 7/1, and 8/2. So my data would be 3 and 0.8, and I don't know what 5/7 is, so let's get that. .71. 3 halves, which is 1.5, 7, and 4. All right, so the mean is all those items added up. So 3 plus 0.8 plus 0.71 plus 1.5 plus 7 plus 4. That's what I got. And then we divide by, how many data points do we have? Yeah, so we divide by 6 equals 2.835. The median is going to be the average between the two middle numbers because I've got 6 data points. So I'm going to order them from least to greatest. And then the 2 in the middle, I'm going to find the mean of those two numbers. So 1.5 plus 3, and cut it in half, 2.25. And then the mode, oh my goodness, we have a scenario where there is no mode. I don't have any number occurring more than once, so there's definitely no mode. All right, now one of my favorite guys in statistics is the outlier. So if we look at the sample problem, which is an outlier for this data set? 56, 65, 73, 59, 98, 65, and 59. So the first thing you do is order the data. Oh, let's get the definition of outlier. I was wondering, well, that's really unusual. So an outlier is a value that is substantially different from the rest of the data in a set. If the data is in one variable, outliers can occur at the ends. They can be misleading because they can affect the measures of central tendencies. Right now, it's just important to write down what an outlier is. All right, so the first step in identifying an outlier is to order the data. And the second step is to find the differences between each of the values. So if you look at this scenario, the differences between 56 and 59 is 3. Then the next one is 0, then 6, then 0, then 8, and then 25. So 98 appears to be substantially different, so 98 is the outlier. All right, so our got it moment is, suppose the values in problem 2 are the data for the situations below. Would we discard the outlier and explain? So A, if these were the water temperatures of a lake at 7 locations, would we discard this 98-degree temperature? So if this were water temperature of a lake, I would definitely discard this 98. It is extremely unlikely that this is an accurate reading. Normally lake temperatures don't get that high. So let's look at it in this situation where, what if this were the number of customers we had at a restaurant? Would we discard the 98 customers? Like this. So for B, I would say no, don't discard. It's probably normal to have an extremely busy night every now and again, like Cinco de Mayo. And especially if you're doing cost calculations or ordering calculations, if you want to prepare for that night, on average, you're ready to feed that amount of people. It's important to know how many are going to be there. All right. So we're going to talk about range quartiles and interquartile ranges. What are we going to talk about here? So the range of a data set is the difference between the greatest and the least values. If you order the data from least to greatest, the median divides the data into two parts. Then the median of each of those two parts divides the data further until you have 4 parts. The values separating the 4 parts of the data are called quartiles, which makes sense because a quarter is a fourth. So it's a fourth of your data. The interquartile range is the difference between the third and the first quartiles. So we're going to talk about box and whisker plots, and I wish it were more complicated, but a box and whisker plot is 2 boxes with a little whisker outside of each end of your boxes. And what it does is it breaks up your data into quartiles. So the distance of this whisker is the first quartile of your data. The distance of your first box on the left is your second quartile. The distance between the median and your third quartile is that third quarter, and then finally the last whisker is your fourth quartile. So by reading this box and whisker plot, if it's really tight together, if it's really close, your data doesn't have a lot of distance in between values. Your data is pretty close. If it's spread way out, then if your box is really long, then you know your data is spread out. So just by looking at the box, you can tell how your data lies. It does need to be graphed on a number line. Without the number line and accurate reading, you can't tell how close or far apart your data values are by the box and whisker. So a box and whisker plot is a way to display data. It's got the quartiles and the minimum and maximum values. It also has a number line at the bottom. So we're going to make a box and whisker plot together so that you guys can see how this shape stands. So step number 1 for a box and whisker plot is to order your data values. So my smallest is 11. Once I order it, I'm going to cross it off my list. Then I have 12. The next one I have is another 12. Then I have 14. Then 2 15s. Then a 16. Then an 18. 2 19s. And a 20. All right, so now let's find the median. All right, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data sets. Odd number means I have 1 median. So let's find our median here. 1, 2, 3, 4, 5. 15 here is our median. So if I have a number exactly in the median, then I'm going to look at these numbers here and find the median of everything on the left-hand side. So once again, I have an odd number. So let's find the median of those values. 12. And I'm going to look at my numbers on the right-hand side of my median. If my median were 2 values, then those 2 values would be included in finding the quartiles. But because I have an odd number, none.
Wouldn't you add them together and come up with?
Right, but when you're trying to find the right-hand side, so this is quartile 1. If you're trying to find quartile 1, and you split the two medians to find the one, you would include the first value for the median on the left-hand side and then the second one on the right. So if I had So if I have 2, 3, 3, and 5, let's put one right here. And 3 is my median, and I want to find the median of the first half. The first half would be 1, 2, and 3. And I have a number in the middle, so if I have the same data set, I have a number square in the middle, then the median doesn't include that 4 of the first set of pages.
Well, what if it was 3 and 4 instead of 3 and 2?
Okay, so the median of the second half of the data is 19 right here, because it splits that second half into 2 sections. So this is quartile 1, this is quartile 2, this is quartile 3, this is the min, and this is the max. My range is equal to 20 minus 11, which is 9. What this tells me is that there are 9 values between my first and my last data point. My interquartile range, or as I like to call the IQR, is how many numbers are between Q3 and Q1. And it is 19 minus 2, which is 7. All right, so let's make a little plot. So I'm going to get my line out. So I have a line, and I'm going to, I know I definitely need 9 tick marks, so here is, that's 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and I'll put 21. Okay, so this is, so you make a little number line on the bottom. We indicate the minimum value. We indicate quartile 1. Put in Q1, that's a Q. Looks a little wonky, looks like an A. Quartile 2 is here. Quartile 3 is right here. And our max value is there. All right, so what we're going to do is we're going to put a vertical line at each of my quartiles. We're going to connect quartile 1 and quartile 3. So we have our box. And then the last thing we're going to do is we're going to put our whiskers. And voila, we have a box and whisker plot. From this, you can say that my interquartile range, or my numbers, are pretty spread apart in my data set. You can tell that a majority of your numbers are between your minimum value and your median. So you have more numbers between 11 and 15 than you do between, they're more condensed right here. So more data values at the lower ends. Well, not more, but they're more, the data is closer together here. I want to real quick talk about percentiles, because I think percentiles are something that we do naturally. We see it so much that we don't fuss with it too much. A percentile is a number from 1 to 100 that you can associate with a data set. It shows the percentage of data that are less than or equal to X. A percentile is from 0 to 100 because you can have 0.5%. To be in the top 0.1 percentile of your class because you're so smart. So let's look at this problem and then we can do our got it problem together. Here's an ordered list of midterm test scores for a Spanish class. What value is at the 65th percentile? The answer to that is, of the 20 values, 65% fall at or below the 65th percentile. So you take your 20 and multiply it by 65% to get 13. So 13 values fall at or below 82%. The value at the 65th percentile. So that you order these and then you go, okay, so 13 of them are 65%. So you start counting 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. So these 13 are at the 65th percentile. Everybody above that is above the 65th percentile. Interesting way. I know you guys hear data in education all the time. Everything you get back from your test scores has you in a percentile. So let's see if we can calculate this information down here. What are the values at each percentile for the data in problem number 5? So the 55th percentile so there's 20 data values. And we want to know how many are 55th percentile or below. Yes. So this says 11, so let's look at, so when we're here, we look at 1, 2, 3, 4, 5, 6, 7, 8, 11. So it's 79, a score of 79 or less. Is 55th percentile. Did you get 19? That's what I got. 20 times 0.95 is 19. So 19 of these values, are in the 95th percentile, so that's 98 and below. There's only one person above the 95th percentile.